Hello friends, a very good morning to all the students. I hope I am audible to all. Okay, thank you all for your answers in the chat box. So friends, you are aware that we are discussing one of the interesting chapter and one of the simplest chapter of the subject basic mechanical engineering. The chapter name that is the pumps, very easy chapter and the scoring chapter. So friends, in the last lecture of the pumps, we have discussed several concepts related to the reciprocating pumps. Also we have discussed the different types of the reciprocating pumps, and we have also understood the concepts of the air chamber or the air vessel. So before starting the discussion of the new topics of the pumps, let me ask you a good technical question of the topics we have understood in the previous lecture. What is the main technical difference between the single acting pump and the double acting piston pump? I am repeating the question once again. Just think over the question and then give me the answer. The question is, what is the main technical difference between the single acting piston pump and the double acting piston pump? What are your comments in this question? You are free to answer in the chat box. Some of the students have responded me their answers. So some students are telling the water delivery is constant in the double acting pump. Some student is telling the output will be more. The inlet and outlet, okay. There are two suction and two delivery pipes in the double acting, okay. So that is with respect to the design perspective of the pump. Water delivery is constant, fine. Single acting acts on only one side, on the double acting it acts on the both the sides, okay. Any other answers? Any student want to share with me? In single acting piston pump, liquid delivery and suction does not happen simultaneously, but it happens simultaneously. Very good, the perfect answer which I was expecting. So I have received that perfect answer from one of the students. The answer was very specific. In single acting pump, the suction as well as the delivery does not take place simultaneously. That means in one stroke there is only the suction, in the second stroke there is only the delivery. But when we consider the double acting pump, the suction and the delivery, both the two strokes takes place simultaneously. And this is one of the most important technical difference between the single acting pump and the double acting pump. Very good. One of the student has responded me this answer in the chat box, and the other answers which all different students have given me, they are also the correct answers. So I think from your answers, your concepts are perfectly clear related to the reciprocating pumps. So now friends, before starting the discussion of the pumps, proceeding to the other topics of the pumps, I hope you have seen the message of our HOD sir that on 14th and 15th the institute will remain closed. It is holiday. Therefore, there will be no lectures on 14th and 15th. So you can enjoy the kite flying to the fullest. And my best wishes for all the students for the kite flying festival. Have a safe Uttarayan, enjoy the festival. Let us friends now proceed further and understand some more topics related to the pumps. So in this session, we are going to understand the basics of the centrifugal pumps. Then we will be understanding the different types of the centrifugal pumps. And then we will understand one of the important concept, that is the priming of the pumps. And finally, we will make the comparison between the centrifugal pumps and the reciprocating pumps. So let us start with the first point, that is the centrifugal pumps. Dear friends, remember that the classification of the pumps we have already understood. There were three types: the positive displacement pump, the rotodynamic pump, and the other pump. So the centrifugal pumps are the type of the rotodynamic pump. Very important point to be remembered. So a centrifugal pump is a type of rotodynamic pump in which the liquid is raised from a lower level to a higher level. And these increases in the level of the liquid is created by the required pressure of the liquid. And for increasing the pressure of the liquid, we are using the centrifugal action. I hope friends you are well aware about the centrifugal force. I hope you have studied the centrifugal force, the effects of the centrifugal force at your school level. So I am repeating the definition once again because friends, remember, the centrifugal pumps is one of the most important topic which can be asked in your theoretical examination. So a centrifugal pump is a type of the rotodynamic pump in which the liquid is raised from the lower level to a higher level by creating the required pressure with the help of the centrifugal action. In general, it can be defined as a machine which increases the pressure energy of the fluid. And after increasing the pressure energy of the fluid by means of the centrifugal pumps, the liquid can be transferred easily to the higher level. The whirling motion is imparted to the liquid by means of the backward curved blades mounted on the wheel which is known as the impeller. Whirling motion is a type of the motion which is developed in the centrifugal pump, and this motion is developed by means of the backward curved blades which are mounted on the wheel known as the impeller. Dear friends, the impeller is one of the most important component of the centrifugal pump. You can correlate the impeller with the fan which we are using at our homes. But in the fan, we observe the fans are having the straight blades. The blades of the fan are straight in the design. But when we consider the design of the impeller, it will be having the backward curved blades. So this is a very important concept in context of the centrifugal pumps. Dear students, are you understanding these points which I am discussing? Are you getting the concepts of the centrifugal pump? Still I am discussing the basic points of the centrifugal pump. Okay, fine. Thank you for your answers. Let us proceed further. So the first image that shows the main components of the centrifugal pumps. Dear friends, this is the practical image which I have used for explaining the concept of the centrifugal pump. The main components of the centrifugal pump includes the centermost point, that is the suction eye. At this point, your input shaft will be connected as well as the suction pipe will be connected. Next important component which is observed, that is the impeller. And in the figure now you are seeing that the impeller is having the backward curved wings. The blades on the impeller, in technical they are known as the vanes. So the impeller consists of the backward curved vanes. This is the special design of the vanes in the impeller. Next important component, that is the volute casing. If you observe the design of the casing, at this point the cross-sectional area of the casing is less, and as we are proceeding further, as shown in the gray color, the cross-sectional area of the casing increases gradually. At this point, the area is less. As we are proceeding further, we are observing the area is gradually increasing. And finally, the maximum area of the casing is connected to the discharge line. In your textbook, at the bottom of the suction pipe, two components will be mentioned, the foot valve and the strainer. The foot valve is a type of the suction valve, the non-return valve. The strainer, it acts as the filter. It removes the impurities and all other foreign materials which are present in the water, and after filtering the water, the strainer then passes the water to the suction pipe and finally to the pump. So now friends, let us understand the basic working. The liquid enters the impeller at the eye of the pump, and finally the liquid discharges into the casing surrounding the impeller. The pressure head developed by the centrifugal action is entirely due to the velocity imparted to the liquid by the rotating impeller. So now, to be more simple in the working, this I section will be connected to the motor or the prime mover. So the prime mover will be providing the power to the I. Because of this power input to the pump, now the impeller will be rotating at the higher RPM. Because of the rotation of the impeller, the vacuum will be created on the suction side. So the foot valve will be opened. The water, after passing through the strainer, it will be transferred to the suction pipe, finally to the suction eye, and the water will be heating the rotating impeller. The water will be heating the vanes of the impeller. That means because of the rotation, the heating of the water will be having the kinetic energy. When this kinetic energy of the water is transferred to the casing, because of the spatial design of the casing, as the water is flowing in the casing, the kinetic energy of the liquid gradually decreases, and this decrease in the kinetic energy is converted into the pressure energy, or can be considered as the pressure head. And at the outlet, when there is the maximum area of the casing, there is the minimum kinetic energy of the liquid and maximum pressure energy of the liquid. Hence, this type of the centrifugal pumps are used for lifting the liquids at the higher heights. So friends, if you observe the image of the centrifugal pump which is given in your textbook, If you observe the different heads, the limits of the suction head is fixed. There is the boundary in the suction head, that is HS. But if you observe technically, there is the no boundary in the delivery head. In the delivery head, 2 arrows are mentioned in your textbook. That means the delivery head is dependent on the pressure head generated by the centrifugal pump. Dear friends, I am moving in some details. I am correlating my topics with your textbook literature so that you are not getting confused and you are clearing the concepts. Dear students, let me ask you, are you able to understand the working of the centrifugal pump? My figure is somewhat different than your textbook image, but I have correlated your textbook image with my figure and understood the points which are mentioned in your textbook. I want the responses from majority of the students if the concepts are perfectly clear. Because friends, this is one of the important questions with respect to the theoretical examination. Okay, thank you all for sharing maximum responses in the chat box. So now friends, let us proceed further and understand the applications of the centrifugal pumps. The first application is in the buildings for pumping the general water supply, and the pump is used as a booster device, and also it is used for the domestic water supply. So in the buildings where the water has to be lifted at the higher heights, generally we are using the centrifugal pumps. The another application of this pump, that is in the beverage industry, which is used for transferring the juices or the bottled water. The another application, that is in the various industries. The various industries can be considered as the manufacturing industry, the chemical, the pharmaceutical, the food production, the aerospace industry, etc. So for different applications of the centrifugal pump for transferring the liquids, the centrifugal pumps are used in such various industries. Also, the centrifugal pumps are used in the dairy industry for transferring the dairy products such as the milk, buttermilk, the flavored milk, etc. But in the dairy industry, in context of the centrifugal pumps, we are not correlating the flow rate. So these are some of the important applications of the centrifugal pump. Let us proceed further and understand the classification of the centrifugal pump. So the first classification is according to the design of the casing. So according to this parameter, the centrifugal pumps are classified into 3 types. They are the volute or the spiral type casing pump. The next one is the vortex or the whirlpool type pump, and third one is the diffuser type pump. As we are proceeding further in this lecture, we will be discussing all these 3 types of the pumps. The next classification of the pumps, centrifugal pumps, that is according to the number of the stages of the pump. So according to the number of the stages, the pumps are classified as the single stage pump and the multi-stage pump. The multi-stage pumps are further classified again into 2 types, such as the impellers in series and the impellers in parallel. In some cases, for some applications, the impellers are connected in series and different impellers are connected, so it can be considered as the different stages. So that pump is considered as the multi-stage pump. And in some of the applications, the impellers are connected in parallel, and it is also considered as the multi-stage pump. So this is the simple classification of the centrifugal pump. Now friends, let us understand the different types of the centrifugal pumps. The same image you will be observing in your textbook. The first type of the pump is the pump with the volute casing. This is the simplest type of the pump. As you are seeing in the image, the centermost point of the pump, that is the I section. Then we are having the rotating impeller. On the impeller, we are having the backward curved vanes, and surrounding the impeller, we are having the casing, and this casing is considered as the volute casing. The most important point in context of the casing is that at this point, the area is minimum, but as we are proceeding further in the casing, the area gradually increases. So this is the simplest type of the centrifugal pump, but the efficiency of this type of the pump is very minimum. The head generated for this type of the pump is also minimum because of the different losses which are generated in the liquid. So, in order to increase the efficiency of the volute casing, some design changes are made in this pump. So, the next type of the pump, that is the pump with the vortex chamber. It is the modification of the volute type pump. In the volute type pump, we have just added one vortex chamber, or it is known as the whirlpool chamber. So friends, in this, how the working will be taking place? If you remember, the liquid coming out from the impeller having the kinetic energy, that liquid will be first moving in the vortex chamber or the whirlpool chamber, and this is a stagnant chamber. So as the liquid is moving in the whirlpool chamber, the stagnant chamber, there will be the decrease in the kinetic energy, and this decreased kinetic energy of the liquid is then passed on to the casing, and now the conversion of the kinetic energy into the pressure energy will be more in case of the pump with the vortex chamber. And if the conversion is more, then we are able to achieve more pressure head, and the liquid can be delivered at a much height. So this is the main difference between the volute type pump and the vortex type centrifugal pump. The third type of the pump and the practically used pump, that is the pump with the guide vanes. Another name of this pump, that is the diffuser pump. In this pump we are observing that surrounding the impeller there is one stationary diffuser. The design of the stationary diffuser is completely the opposite of the impeller. And friends, remember the term, it is a stationary diffuser. So there will be no movement in the diffuser. The diffuser will be stationary, will be steady. The water which is coming out from the impeller having the kinetic energy will be heating the blades of the diffuser. And since the diffuser is constant, steady, stationary, the kinetic energy of the liquid will be reduced significantly. And this reduced kinetic energy of the liquid is then transferred to the casing, that is at this particular point where the area is minimum. Then this lesser kinetic energy liquid is passed on to the casing. In the casing, the conversion of the kinetic energy into the pressure energy takes place. And the pressure head is very much developed in this type of the pump. So considering the practical applications, majority of the cases we are using the diffuser type of the centrifugal pump. But if we consider the maintenance and the initial cost, then they are comparatively higher for this type of the pump. So friends, these are the three different types of the centrifugal pumps on the basis of the design of the casing. Let us proceed further and understand the most important topic related to the pumps, that is the priming. Very easy topic, just understand the technical concepts and you will be perfectly understanding the topic of the priming. When the pump is first put into service, that is for the particular application, its passageways, example, the suction pipe, the casing, the delivery pipe, are filled with the air. Remember friends, during the first application of the pump, we have not supplied any of the liquid. So all the passageways, the suction pipe, the casing, the delivery pipe, that will be filled with the air or some impurities. If the pump is running with the air, the pressure head will be generated in terms of the meter of air. And if the pump is running with water, the pressure head generated is in terms of the meter of water, which is very obvious, self-explanatory. But we are knowing that the density of the air is very lower. Therefore, the pressure head generated by the pump with the air is negligible compared to the pressure head generated by the pump with the water. Hence, if the passageways are having the air filled in it, then during the first operation of the pump will be initially not sucking the water, but it will suck the air from the suction tank. And there will be the drawback of the pump in transferring the liquid from the suction tank to the delivery tank. So in order to avoid this drawback, in order to avoid this condition, before starting the pump, the air must be compulsorily removed from the passageways. If the air is not removed, then the pumps will be sucking the air because of the lesser density of the air, and we will be getting no liquid at the out. So friends, is this concept clear up till this point in concept of the priming of the pumps? Are you understanding the points? Is the concept clear related to the priming? I want your responses in the chat box so that I can proceed further. Okay, thank you for your answer. So now we will be understanding the exact definition of the priming. Very important definition. The priming is an operation of filling the passageways, suction pipe, casing and delivery pipe up to the delivery valve from outside source with the liquid to be raised before starting the pump. That means before putting the pump in the actual application, first the pump must be primed with the liquid which is to be transferred in the practical application. And if you have observed practically also, whenever we are installing the pump, firstly we need to follow the process of priming. And when the priming is done in the pump, the air filled in the passageways, the different impurities filled in the passageways are removed by the liquid, and now the pump is ready to transfer the liquid from one place to the another place. There are different methods of the priming. The first method, that is the manual priming. By manually we are doing the priming. The second method is priming with the vacuum pump. The pump is attached with a vacuum pump. So operating the vacuum pump, the vacuum will be created, and this vacuum pump will be forcing all the impurities, all the air present in the passageways, and then we can use the pump in the practical application. Next method of the priming, that is priming with the jet pump. We are using the jet pump. With the pump, in the jet pump, with the help of the injector, we are injecting the liquid at the high pressures inside the pump, so that the air contained in the passageways, the impurities filled in the passageways, are removed by this high pressurized jet of the liquid, and then we can run the pump effectively in the practical application. And finally, the last method of the priming, that is priming with the separator. So in the separator, the liquid is first transferred so that the different air molecules or the different impurities are first removed, and then the liquid is transferred to the pump, and the pump can be effectively used in the practical applications with the higher efficiency. So friends, in your textbook, the different methods are given, the figures are also given. So kindly understand those figures, and you can understand perfectly the concept of the different methods. Let us proceed further and understand the last point of this session. Comparison between the reciprocating pump and the centrifugal pump. Very easy to understand the classification if the concepts are clear in both these pumps. So the first parameter, that is the working principle. Today only we have understood the centrifugal pump is a type of the rotodynamic pump, and in the last lecture we have understood the reciprocating pump is a positive displacement pump. The type of the flow which is available at the outlet. So when we consider the centrifugal pump, the type of the flow is smooth and even. But in the reciprocating pump, by the reciprocating motion of the mechanical element, we are getting the pulsating flow, that is the intermittent flow. Floor space requirements, the centrifugal pump requires the lesser area, and the reciprocating pump generally requires the more space for the installation. The gross weight, the centrifugal pump is considered to have the less weight, but in the reciprocating pump, because of having several mechanical elements, complicated mechanical systems, the reciprocating pump is having comparatively high gross weight. Next point of comparison, that is the installation of the pump. The centrifugal pump, the installation is very easy, and for the reciprocating pump, it is considered to be somewhat difficult with respect to the centrifugal pump. So these are some of the points of comparison. Let us proceed further and understand some more points related to the comparison between these two pumps. Next point of comparison, that is the efficiency of the pump when we are considering the low head pumps. For determining the efficiency, I am considering a common parameter, that is the low head pump. So for the low head pump, in terms of efficiency, the centrifugal pump is having the higher efficiency, but the reciprocating pump, the efficiency is lower. It is almost the 40%. Considering the construction of both these pumps, the centrifugal pumps are considered to be simple in construction, but the construction of the reciprocating pump is complicated. Next point, that is the initial and the maintenance cost. The centrifugal pumps are having the lower cost in context of the initial and maintenance cost, while when we consider the reciprocating pumps, the initial and maintenance costs are comparatively higher. And the last point of comparison, that is the pump speed. In centrifugal pump, the pump speed is very high. In the reciprocating pump, the pump speed is lower. Now friends, let me ask you one of the technical question. Why in the centrifugal pump, the pump speed is higher? Why in the centrifugal pump, the pump speed is higher? The pump speed, we are considering the input parameter. The input rotation of the shaft, that is considered as the pump speed. So my question is very easy. Why in the centrifugal pump the pump speed is kept higher? Okay, I am getting some of the responses from the students. Just understand the technical perspective. The answer will be clear to all. Okay, I am getting some other answers. Fine, different students are giving me the different approach, different answers I am getting. Okay, the rotating blades moves with the greater speed. Okay, can be considered. Water come with the more kinetic energy. Okay, can be considered. I am happy to see the responses from the different students. They are thinking in the good technical manner. Some of the students are considering the cavitation effect. Okay, can be considered. So friends, the simple answer to my question, that was, if the pump speed is higher in case of the centrifugal pump, then because of this high speed of the pump, the centrifugal force produced in the impeller will be increased. When I am increasing the centrifugal force of the impeller will be sucking, receiving more and more amount of the liquid from the suction tank, and we are able to transfer more amount of the liquid with the high pressure head from the delivery side. I hope you have understood my simple answer of the technical question which I asked you. To be more simple, the pump speed in case of the centrifugal pump is higher, very higher, in order to increase the centrifugal force. And by increasing the centrifugal force, the more kinetic energy of the liquid will be converted into the more pressure energy of the liquid. So friends, with this, I am concluding the session from my side. Thank you for watching the current session. In the next lecture, we will be discussing some other types of the pumps. Now the session is open to all. If you are having any questions, you can ask me in the chat box. Any question from any student related to the topics discussed in today's session? All were the important topics that can be asked in your theoretical examination. Okay, I am not getting any of the responses. That means the concepts are perfectly clear. So I am ending this session.